haven't done very well in terms of inviting all our friends here to join. We haven't done very, very well. We haven't done very, very well. Because I can see we are at 33, which is quite a nice number, but you see that is not our best. This class, for instance, at RCM, we are over 200 students, So I expected to even get more. Of course, I know some of you could be working. That one is not lost on us, but still, we can get much more than 40 students. We'll not stabilize at 40 students. No, we need more students, and then I'll be able to do very few questions. I'm doing very few questions, and then we'll be able to gauge our performance after your exams are done. So we are given a very simple question here, input-output matrix, November 2019, question number 1, cow, where they're telling us that a small economy has two sectors, X1 and X2, producing a single product. And then they have given us this information, what we call input-output matrix. So remember production sector, this one here is also known as the output. Purchaser sector is known as the input. And then they have given us what we call consumer demand, also known as what here, final demand. The projected consumer demand changes to 400 units and 800 units for X1 and X2 respectively. Required, determine the gross output. So if you're finished taking this question down, ladies and gentlemen, could you kindly put your thumbs up like this? Or simply write there Y for yes. Simply write there Y for yes. On your chat area, Y for yes. Y for yes, and then I'll be able to know what to do. So I have many new messages. Thank you so much. They're telling me, Mwalimu, already we have this. So remember, this is what we call input-output. In terms of applications of matrices, in most cases, you will get them testing you on the Markovian processes or this input-output. All right, remember this is under matrices. The very first thing that you're supposed to do in this kind of a question is to demonstrate understanding, deeper understanding of the subject by writing down the prediction model. How do we get to predict the total output? Very easy. To predict the total output, so solution, to get total output, which basically will be our X. Yeah, we shall come here and say X equals I minus A inverse multiplied by D. This is the formula we shall be using. So in this case, ladies and gentlemen, this is called identity matrix. And it shall be a 2 by 2 matrix. Why 2 by 2? Because we have got two sectors, X1, X2. If you had 3 sectors, it would have been a 3 by 3. Yeah, it will be a 3 by 3 matrix. So this is not 1. It stands for identity matrix. And if it is a 2 by 2, then our identity matrix here will be 1, 0, 0, 1, like that. That will be the format. So we have 1, 0, 0, 1. So you can see it has got 2 rows with how many columns? 2 columns. 2 rows by 2 columns. 2 rows by 2 columns. If, for example, they told me, ladies and gentlemen, to write a 3 by 3, don't write this. This is not part of this question. If it was a 3 by 3, I know how an identity matrix here looks like. It would have been 1, 0, 0, 0, 1, 0, 0, 0, 1, because an identity matrix is that matrix whose the main primary diagonal has 1s. And then all the other figures are what here? Zeros. The main diagonal has 1s, and then of course we have zeros here. We don't want to write this. These are 3 by 3, and yet we are doing what here? A 2-sector question. We are doing a 2-sector question. So this is our identity matrix. That is identity matrix. And then, ladies and gentlemen, we have our A. Our A, in this case here, is our technological or technical coefficients matrix. Technical coefficients matrix. Technical coefficients matrix. Technical coefficients what here? Matrix. Technical coefficients matrix. Technical coefficients matrix. For us to be able to get this technical coefficients matrix, we need this information here. We need this information here, ladies and gentlemen. And this information, this is what we shall do with this information. To be able to get this technical coefficients matrix, there are those fundamental assumptions. The first assumption is this one here. We know that for any model to work, our total output should be equal to the intermediate demand. Intermediate demand will be equal to the intermediate demand plus final demand. So remember, we have got two types of demands. Yeah, just like, for example, if you are in the agriculture sector, you've been able to produce maize. If you produce maize, during those great old days, you will have to retain some maize and use whatever maize you've retained as seeds. So you see, an output from a sector is being utilized as an input in the same sector. Yeah, so that is demand from within. That is what we are calling here intermediate or internal demand. Demand from the very sectors. And then some of this, assuming you produced 100 bags of maize, 10 will be consumed by the sectors for further production, and then 90 will be given outside there. Whatever goes out of the sectors is what we are calling the final demand. The demand that is coming from consumers. So final demand is also known as what here? The consumer's demand. So anytime they want you to get total output, you must always remember this. The total output equals intermediate demand plus final demand. So ladies and gentlemen, remember this is the demand. So the units that will be consumed by the X1 and X2, the sectors, so these two, these are what here? Intermediate, yeah? And this is what we call final demand. Therefore, my good students, please listen and listen to me very well. To be able to get this total output for my two sectors, which is X1 and X2, what do I need to do, my good students? What I need to do here is to come and take this intermediate demand of 500 plus 800, in this case here, plus what here, plus 200, plus that 200. That is for X1. For X1, I'm taking what X1 will consume itself, what goes to the other sector, 800, and then what will go to the consumers, what we are calling the final demand. I'm using this one here. So can somebody in this case here give me this figure for X1? So the total output for X1 will be equal to what? Yeah, please help me get these figures. We shall pass. Don't worry, we shall pass. We shall pass. So in this case here, I'm being given by Dama 1500. I hope everybody is able to see this. That is X1. Thank you so much. For X2, what do we have? For X2, ladies and gentlemen, what we have here for X2, I can see X2, we have 600 being consumed by X1, plus what it will sell to the other sector, plus now what will go to the consumer demand as 400. So is there somebody who is able to give me this figure? Is there somebody who is able to give me this figure? Anybody who is able to give me this figure? 2400. So this is now what we bring to this matrix here. This is now what we bring to this matrix here. This is what we bring here and call it total output. So we have here the total output. So the total output for X1 is 1500, and then for X2, it is 2400. 1500, and then for X2 is 2400. This is really an important step for the number of years I've marked KASNEB exams. I get to see many students get it wrong here. And the moment you lose it from this very step, then you shall be able to get 0 in the entire question. So that is step number 1. Ensure you're using this concept here. And then concept number 2, the second concept that we have to utilize, can I rub this? Can I rub this? Total output equals intermediate demand plus final demand. Yes. So the other concept still, on this total output, we know that our model is never a model of losses. There are no losses to be made. Our total output will always be equal to total input. Total output will always be equal to total input. Very, very important. Very important. This one, if I were you, I would have used a yellow highlighter, written this and used a yellow highlighter to highlight this second basic step. The total output equals total input. So it means that I need to come here and create a row for total input. Can somebody in this case here guide me? What do you think will be the total input for X1? What do you think will be the total input for X1? Total input for X1. Total input for X1. Can somebody in this case here help me? What do you think will be the total input for X1? Please help me. Yeah, so somebody has done that mistake, which is very, very good to do mistakes. Collins here, they have added. When you add, you're disregarding this important concept. The total output will always be equal to total input. So the total output of X1 will be equal to the total input, which is 1500, like that. Yeah, the same for X2. The total output of X2 will be the total input of X2 here, 2400. Yeah, great. But now good students will ask me, Mwalimu, this particular column is not balancing, is not agreeing to this. Normally the difference comes as a result of what? Can somebody tell me? Like now we know there is a balancing figure of 400. Yeah, because you need 400 here to be able to get 1500. The balancing figures, which should never scare you, is what we call the primary inputs. Primary inputs. But that should never scare you. Hakuna losses. This model does not have losses. Jacinta, thank you for trying. This model does not have losses at all. That's why you're using this concept of total output equals total what here? Total input. You see, ladies and gentlemen, there are many factors of production. So if, for example, we have two sectors, sector 1, sector 2, output from sector 1 will be utilized by sector 1 and sector 2. But there are those particular inputs which you can't get from other sectors. There are those primary inputs, the factors of like land, like the entrepreneurship, if you remember those things. We might call them primary inputs. Yeah, so in this case here, perhaps if you would want, you can just include their primary input, but that is not really important for you. Not important for you. The most important thing is for us to know that the total input will always be equal to the total output. After that, now I will be able to get the technological coefficients matrix. Technological coefficients matrix. So my technological coefficients matrix A. Matrix A, which is also known as the input ratios. Input ratios will be equal to, we get these proportions based on the input, based on the total input. So this will be 500 over 1500 downwards, 600 over 1500 downwards. When I come to column number 2, so column number 2 now we are using this as the benchmark. So divided by 2400, divided by 2400, like that. We call this input ratio. Remember in Markovian process, we normally go this way. But in this case here for the input technological coefficients matrix, we normally call them input ratios. Ratios are attained by looking at the input for each sector, the input for each sector. All right. So then go ahead and give me my matrix A. Remember, this is called matrix A. So matrix A will be this X1, X2, X1, X2, just these ones alone. Yeah. So give me how many decimal places? 3 decimal places. 3 decimal places will be so nice. 3 decimal places will be so nice. 3 decimal places will be so nice. So like you have here 500 or 1500, give me an answer I write. Give me an answer I write. $500 over 1500. So please give me it cannot be 2. It cannot be 2. It will be 0 point something, right? Not unless it's a typo. Not unless it's a typo. It will be 0.33, isn't it? Let's do 3 decimal places, eh? 3 decimal places, right? 3 decimal places. Thank you so much. How about 600 over 1500? It has to be 0 point something. 600 over 1500. 0.4. Thank you so much. Great. We go to column number 2. So column number 2, we have 800 divided by 2400. Thanks, Collins. Thanks, Ahmed or somebody. Yeah. So the second one, I'm being told is 0.33 as well. 33 as well. Thank you so much. And then lastly, here we have 1400 over 2400. 1400 over, so 0.583. So now you have your technical coefficients matrix. So if I was to pause there a little bit and ask you, up to where we have learned, if I was to stop this class at this particular juncture, what will you say is your takeaway? What is your take home? What is it that you have been able to understand like fully? Any 2 great concepts you can type there very fast, your area of understanding. What will you say? I've understood this. Mm-hmm. 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 Yeah, I like what in this case here, this lady called Jacinta is telling me that Mwalimu, I will never forget the concept of the total input being equal to the total output. Or rather, what Dama is also telling me, total output equals total input. Equals total input. Thank you. Any other area of learning? There are no losses. Thank you very much. There are no losses because the inputs must always be equal to the outputs. The inputs must always be equal to the outputs. Thank you very much. There is one area you guys haven't yet mentioned on total output, the productivity. That whatever every organization, every sector produces will be able to meet the 2 types of demands. So we have intermediate demand plus final demand. Plus final demand. And then Brian is saying, calculation of A, brilliant. That I've understood. Thank you very much. And then now don't forget, once you have been able to do that, now you are at home. Now we are at home. Now we are at home. Now we should be able to finish this question pretty fast. Pretty fast. So then we know that our Leontief. So we know that our X will be equal to I minus A inverse multiplied by D. So then let's, in this case here, get the Leontief's matrix. It's called Leontief like this. Leontief. Yeah, Leontief's matrix. Leontief's matrix. Leontief's matrix here. So the Leontief's matrix is I minus A. I, we have said I is 1, 0, 0, 1. Minus our A matrix, which is this one, which is 0.333, 0.333. Then we have a 0.4. Then we have 0.583, like that. Yeah, so you go ahead and do the subtractions for us. Whenever you are doing the subtractions, ladies and gentlemen, always ensure that it is corresponding terms that we are subtracting. So our I minus A will be equal to this minus 0.33. Yeah, this minus 0.33. So I hope you guys have your calculators. Yeah, remember we are retaining, Jacinta, 3 decimal places. 3 decimal places. I always work with 3 decimal places. 3 decimal places. So the first one will be this minus this. Yeah, 0.667. All of us, we have to provide figures. We must provide figures and ask questions. And ask questions whenever you're not able to understand. Then come and pick this minus this. So this will give me minus 0.333. All right. And then we have now this corresponds to this. This and this subtracted gives me minus 0.4. Use your calculator always. And then the last one is this minus this, which I would want to see answers from several of you. So we have this corresponds to this. So 1 minus this gives us what answer? Yeah, 0.417. Thank you very much. 0.417 like that. So that is I minus A. But now remember, the examiner wants us to inverse this matrix. The examiner wants us to inverse this matrix. To inverse a 2 by 2 matrix, we will have to go through two basic steps. We'll have to go through two basic steps. So number one, we get the determinant of I minus A. So come here and give us the determinant of this I minus A. Is there somebody who remembers the formula of getting determinant? Oh yes. To get determinant, we normally take PPD minus PSD. Determinant equals a product of primary diagonal minus product of secondary diagonal. Product of primary diagonal minus product of secondary diagonal. Please write like that. Product of primary diagonal minus product of secondary diagonal. So remember our rectangle, our usual rectangle. So we have here A, B, C, D. Then we shall have AC being a diagonal. And that diagonal, which starts from the first element of the matrix, even if you are left-handed, if you're told to write this entire matrix, you shall start writing from this number here, with this number here. So that diagonal which starts from here and moves like that is the primary diagonal. And the product means you multiply. So you'll be able to come here and give us 0.667 times 0.417. You put brackets like that. This minus another bracket. So from there we have this as our secondary now. So our secondary will be minus 0.4 times minus 0.333. So use your calculator just one touch. In Kenya they say one term. I'm not a politician. I just want one touch. In your calculator you say open bracket. 0.667 times 0.417, you close. Then you say minus, open bracket. You take this, then you say close. Could you kindly give me your suggested answer? Could you kindly give me your suggested answer? Could you kindly give me your suggested answer? 0.411, 0.1449. Remember, we shall restrict ourselves to how many decimal places? Three decimal places. In all my teachings, I always work with 3 decimal places, be it probability theory, 3 decimal places. Yeah, so 3, so you're getting 0.1, we are getting 0.145. Is this true? Are we able to get this? So I'll be able to invite you to my advanced level classes. Yeah, and then you see how we normally work things out with my advanced level students. Every person is a participant. Every person provides figures. Even if you provide wrong figures, so what? We are here to learn. It can't be like 2 or 3 people only giving us figures. It is everyone's business to provide figures. And that is the approach we shall adopt because we want to learn maximally. So thank you very much. So you've been able to get the determinant of I minus A is that figure. Thank you very much. Then the last step, now you will be able to come here and define the inverse. Now you define the inverse. Last step, you define the inverse. You define the inverse of I minus A. I've rubbed that matrix, which is very bad. I've rubbed this matrix, which is really, really bad. It is supposed to be 0.667, 0.417. Yeah. then we have minus 0.4, then we have minus 0.333. So this is our I minus A. So now we want to define the inverse, I minus A inverse. How do we get this? We normally take 1 over the determinant, 1 over the determinant into 1 over the determinant into. When you get now to definition of the inverse, you normally do two things. You say 1 over the determinant you got here. And then inside this matrix, two things again. We swap primary elements. The primary elements, these are the primary diagonal elements. We swap them, we exchange them, we interchange them. So this goes here, this comes here. So we have 0.417, 0.667. The secondary elements, these ones, we leave them where they are, but we change their signs. So like now this is negative. In the inverse form, it becomes positive. So this becomes positive 0.4, and this becomes positive 333, like that. That is the inverse. That is the inverse. This is the inverse. This is the inverse, like that. This is the inverse. So you define the inverse. To get our inverse, it is I minus A inverse, which will be 1 over the determinant into the primary elements. We interchange them. And then the secondary elements, we leave them where they are, but we change their signs. We change their signs. Here I know the mistake that so many people make. Very many students, they'll come and tell you 1 over the determinant into, they go back to the original matrix A. They go back to this matrix, they start swapping this. No, remember the matrix was the inverse we want is I minus A. Is I minus A. Yeah, you interchange both. Let's see here. So remember, you interchange, you take this, exchange. All right. But now remember, the secondary elements, you leave them where they are, but change their signs. You change their signs. So Lucy, remember, what do we do now here? We always, primary elements. Like now, if, for example, you have a matrix like this, let me just show you something very nice here. If you have a matrix like this, if you have a matrix like, for example, A, B, C, D, assuming that this is a negative, all right? So then to get the inverse, what I will do, I will come and say 1 over the determinant into, this is primary. Primary elements, what do? We swap them. We swap them. So D goes there, A comes here. So we have D, A. How about secondary elements? They remain where they are, but you change their signs. Like now, this was positive, now it becomes negative B. This was negative, now it becomes what here? C, like that. I hope now this makes sense. And thanks for asking a question. So is that okay, ladies and gentlemen? Is that okay, ladies and gentlemen? Great. So then I can move on to the next concept here. I can move on to the next concept here. Remember, at the end of the day, we are using the Leontief's model to predict the demand, to predict the total output, what should be produced by these sectors. What should be produced by these sectors? So the model is X equals I minus A inverse like that, multiplied by D. So remember, this must be new consumers' demand, the new demand, the demand in the question. So then our X will be equal to 1 over 0.145 into this one here, 0.417, 0.4, then we have 0.333, then we have 0.667. So you come and multiply this by our new demand, our new final demand, or our new consumer's demand. So is there somebody who is able to see the new demand from that question that I had given you? This question that I had given you. Remember, there is the consumer demand that is on the table there. I don't want that. I don't want that. The demand which I need is the demand where they're telling us, my good students, they're telling us there, the projected consumer demand changes to the new demand. The projected consumer demand changes to 400 and 800, the new demand. So 400 versus 800. And this has to be in form of what here? In form of a column. In form of a column. 0.667 minus 0.33. 0.4417. Where are we getting? Subtraction. Now, remember, you are the ones who gave me these figures. I can't remember very well, but you are the ones who gave me these initial figures. I hope you are the ones who gave me these figures, right? And these are the figures you gave me, the I minus A. You gave me 0.667, if I'm not wrong, minus 0.4. Then we have minus 0.33, and then we have 0.417. Now, when it comes to inversing, there are two rules. You will be able to exchange the primary elements. Exchange the primary elements. So this goes up, this comes down. So like that. And then the secondary elements, these ones here, the way they are, you leave them here where they are. And then you change what here, their signs. They retain the positions, but you change their signs. Let me ask you a question. Had you already done this topic in your class? Have you already done this question in your this topic in your class? It's good for me to know so that I can know the speed that I move with. Okay. You have done it, right? Okay, you've done it. Great. Great. You've done this. You've done it. You've done it. Great. 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 So, ladies and gentlemen, then come here and do formulating A. I'll be able to repeat, yes. I'll be able to repeat. How do we get A? I'll be able to repeat. For now, just allow me to finish. So then, first of all, when it comes to multiplying, leave the constant out. Leave this constant out. Yeah. And then come and do the matrix multiplications. How do we do matrix multiplications? Remember, a row multiplies a column. A row multiplies a column. Yeah, a row multiplies a column. It is what we used to call in secondary school, you move down the ditch. Down the ditch. A row multiplies a column. So in this case here, the first ones will be multiplied plus the second ones. So we have here 0.417 times 400 plus 0.4 second ones, 800, like that. So you come and do the same with the second row. So this second row to multiply this. So this by that. So it will be 0.33. So first one's multiplied times 400 plus second one's multiplied 0.667 times 800. All right. So then are you able to give me these values? So X will be 0.145 into, is there somebody who can just use their calculators? 0.417 times 400 plus 0.4 times 800. What value are we getting there? What value are we getting there? What value are we getting here? If you want to know QA very well, I'll be able to advise you. I'll be able to advise you. You just type, and then whatever answer you get, you don't care whether it's right or wrong. Just give us an answer. Give us an answer. Yeah, according to Anoham, he's getting 486 point something. Let's see from other students. And you should be quite fast. Don't fear anything even if you get it wrong. So what? We are blessed. We shall be able to pass. So according to, yeah, they're getting the same. 486.8. That's the first one. How about the second one? You take this times this plus. Don't write like just this and then you write down. No, no, no. Your calculators are powerful. You shall take 0.333 times 400 plus 0.667 times 800. You give me an answer, I write down. So according to Anoam, yeah, I will wait for another student to give me this, yeah, to confirm. Jacinta as well has confirmed 666.8. Thank you so much. Now you can use the distributive law. So now you take this times each one of them. So we have 1.145 times 486.8. Then 1 over 0.145 times 666.8. So give me final answers. You give me the final answers. Remember now you're using distributive law whenever you're opening a bracket. So this will be applying. Those ones will be applying. Those ones will be applying. So please give me these final answers. So this is 1 divided by that times 486.8. And what I know, I'm able to tell. You know, I've taught for so long. If you come to my classes, advanced level classes, you can't get any class which has less than 500 students. All my classes really are very, very big. Yeah. And I'm able to tell from the word go. If you're not giving any figures at all, you're failing to give figures, you're failing to ask questions, you cannot pass. This paper is an intense paper. It needs students who ask questions. Students in this case here who keep on making contributions in class. Even if you're not understanding, use emojis, you cry there, you laugh there. You must be lively. You must be lively. So in this case here, they're giving me 33.57. 33.57.241. 0.241 like that. And then the second one is 45.98. 45.98.621. Thank you so much. So and that is the end of this question. So x1 is equal to that. This is x2 like that. X2 like that. And then I'll be able to answer this great lady who asked a question. I love students who ask questions a lot. She was not able to understand how I was able to formulate my matrix A. Matrix A. And please feel free to also ask your questions before we go to any other question, or rather to any other new question from KASNEB past paper. We must keep on repeating these things until you understand them. So this is what happens, my good students. Oh, Brian is getting different figures and I've rubbed. We shall overcome. Got lost in the universe. Okay, we shall overcome. Okay, so now remember, you'll be given this kind of an input, output matrix. So you'll be given here inputs. This is another exercise. You'll be given here outputs. So this is x1, this is x2. This is x1, this is x2. Then they'll come and give you final demand. Final demand, yeah. So they'll give you, this is 20, 30. Yeah, final demand is, for example, 100. Yeah, x2, in this case here, we have, for example, 40, maybe 60. Final demand is 200. Yeah, and then you will be required here to determine matrix A. Determine the technical coefficients matrix. Technical coefficients matrix. They are getting different figures, okay. They're getting different figures, okay. Okay. All right. So what you're supposed to know, ladies and gentlemen, if you are given this kind of a matrix, what should be our first step? Our first step should be, number one, to know how this model works. The total output will be equal to intermediate demand, or inputs, intermediate inputs, yeah, plus what we call final demand, or consumer demand, final demand, or consumer demand, like that. You know, these are the, like if it's X1 from whatever it produces, it has to retain itself 20, sell 30 to X2, and then we have 100 going out there to be consumed. So then come and create another column here of total output, and they basically use this formula. So total output, now you are adding everything here, this plus that. So kindly give me this value. So 20 plus 30, that's 50, plus 100. So they're getting here 100 what here? 150. Yeah, so we shall be able to move very slowly. These are just an example that I have picked from my mind, which is very, very similar. Yeah, how about the second number? Please give me the second number here. 40 plus 60 plus 200. We are getting, Ronald's, maybe it's a typo. Maybe it's a typo. We are getting, in this case here, 300. Check, Ronald, 300. Thank you so much. It was a typo. Now, after this, ladies and gentlemen, could you kindly guide me? What do you think in this case here will be the next step to be able to get this matrix A? After I do this, what do you think will be the next step? What do you think will be the next step? After I do this, what do you think will be the next step? What do you think will be the next step? Abracadabra. Because remember, A is all about ratios. A is all about ratios. A is all about ratios. So find the input ratio, divide input by the total output, divide input by the total output of each. Great. The first thing you're supposed to tell me is that we have another total output concept. We normally say total output equals total input. Total output equals total input. So that now you come here and they give us the total input here, total input, which will be identical to what you have here. So you have here 150, 300, but now you write them like this. Yeah. So please, when you're getting total input, don't add these figures. Don't tell me that the total input is 60. No. No. Because you will be defining this. Total output must be equal to total input. Now, after you've done that, you'll be able to do exactly what you guys have told me. Now get the ratios. So how do we get the ratios? Which are matrix A. So like now, every figure here will be divided by 150 downwards. 150. Every figure of X2, you divide by 300 downwards. 300 like that. So now this will be able to give me my matrix A. My matrix A. So then please give me these values in 3 decimal places. So you give me 20 divided by 150. How much are we getting? 20 divided by 150. How much am I getting? 20 divided by 150. How much am I getting? 0.133. Then we have 40 divided by 150. 40 divided by 150. 0.266. Yeah. And then we come to the second. Remember, this matrix A does not, don't tell me do 150 or 150. No. Matrix A captures only relationships between sectors. Yeah. So 30 over 300 is 0.2, 0.266, 0.267. So it's supposed to be 0.267. Yeah, 3 decimal places. So this one here is 0.1. And then 60 divided by 300 is point. Thank you so much. Now you guys have started knowing the trick. The trick to this thing is speaking. 0.2. So this lady who asked this question regarding formulation of A, are we now together? Are we together? The lady who asked about formulation of A. Have you now known how to formulate it? Great. Thank you very much. Thank you very much. Now, after that, another student has asked about the input, or rather the inversion. Inversing. Ladies and gentlemen, inversing a matrix, don't write this. This is just for my board. Don't write this. This is for my board. So if, for example, you are given a matrix like this, you are given a matrix like A, say 6, 8, -3, 4. And then somebody tells you, in this case here, to inverse this matrix, to get A inverse. Somebody tells you to get A inverse. How do you do it? Very easy. First, you give us the determinant. So determinant, we know it is PPD minus PSD. Product of primary diagonal minus product of secondary diagonal. So primary diagonal is the one that starts from the first element. It moves like that. Primary, primary, primary. The one that starts from the first element. Yeah. So primary, the product means you multiply 6 times 4, you put brackets. Minus, open bracket for the secondary. Secondary is the other one, also known as a lagging. So minus 3 times 8. So is there somebody who is able to give me this answer right away from their calculator? 6 times 4, open brackets always, close, minus open, minus 3 times 8, you close. Give me an answer, somebody. Yeah, thank you so much. Now you're getting the secret to this. You must always be on top of things in terms of giving numbers. So 48. Thank you so much. So now once you have done that, you'll be able to come and inverse this matrix. So A inverse. What do we do with A inverse? We shall take 1 over the determinant into 1 over the determinant into. What do we do inside here? We interchange the primary elements. You interchange the primary elements. So primary elements interchanged. So we have here 4 versus 8. 4 versus 6, sorry. How about secondary elements? You leave them to be in their respective positions, but you change. So minus 8, the sign. Initially it was positive and it becomes negative. So this becomes positive 3, like that. So this young man who asked about this inversion, have you now understood how to do it? Yeah, you take 1 over the determinant into, inside the brackets, you identify the primaries, swap them. Secondary elements will be left where they are, but you do what here? You change their signs. So then let's now proceed with this question of ours. Let's proceed with this question of ours, my good students. So if they wanted me to continue with this question in terms of predicting my total output, I know the formula. The total output, I know the formula should be total output equals the Leontief's matrix, not just A alone, inversed. Leontief's matrix inversed multiplied by final demand. So I'm 100% sure where students will always have issues, it is in this inversion. Most students are not able to inverse. So then, ladies and gentlemen, we shall be able to first of all get this that is in the brackets first, body mass. What is in the brackets is I minus A. So come here and say I minus A. Remember your A is 2 by 2. So the identity matrix will be 2 by 2. So 1, 0, 0, 1, like that. Minus A. My A is 0.133, 0.1, 0.267, 0.2. So you go ahead and subtract. So is there somebody who is able to subtract for us, ladies and gentlemen, pretty fast? Because we're getting I minus A. So remember, it is about corresponding elements, like this corresponds to this. So you say 1 minus this, give me an answer. Yeah. So the first one, according to Jacinta, I'm just waiting for confirmation, like from 2 or 3 students to confirm with us. 0.867. 0.867. So this and this gives me 0.867. Then we have this and this, 0 minus 0.1. So this gives me minus 0.1. Then we have minus 0.267, minus 0.267. Then we have 1 minus 0.2, giving us 0.8 like that. So that is I minus A. Once I get that I minus A, the next thing will be for me to get the determinant of this I minus A. Please remember, I will be using this final demand. These figures, I'll be using them later. So I'm circling them because I'll be rubbing this. All right. So I want what we call I minus A determinant. So we have here I minus A determinant, which is PPD minus PSD determinant. It is product of primary diagonal minus product of secondary diagonal. And remember, you're not going back to this matrix here, A, it is I minus A. This matrix that you found here, this is the primary. So that primary is what you multiply. So we have here 0.867 times 0.8. You close bracket minus product of secondary. This is the secondary. The secondary is minus 0.267 times minus 0.1. So please, using your calculator, are you able to give me this determinant? Are you able to give me this determinant using your calculator? Come and say open brackets there. 0.67 times 0.8 minus open brackets minus 0.267 times minus 0.1. Yeah, then give me your answer, and I can assure you, the students you are seeing who are writing figures here throughout, we shall check with yourselves come next semester. Even if they're giving us wrong answers, so long as they're just participating. It's all about participation. It's all about participation. I've been in this game for over 25 years now. I know how things operate. It's just about participation. Yeah, so 0.667, so 0.667. Now from there, then go ahead and now talk about I minus A inverse. So I minus A inverse will be 1 over 0.667, that is the determinant, into what do we normally do to primary elements during inversion process? What do we normally do to primary elements? Is there somebody who knows what we normally do to primary elements? What do we do to them? Primary elements. We interchange them. We interchange their positions. So like this comes up, this comes down. So we have here 0.8, and then we have here 0.867. How about in this case here secondary elements? How about secondary elements? How about secondary elements? We just change their signs. We change their signs only. So both of them were negatives. Now they'll become positives. So we have 0.1, we have 0.267, like that. Great. Thank you. It remains the same, but we change the sign. Thank you very much. Now from there, remember the formula. So the formula here is total output equals whatever you've gotten here times final demand. The other mistake that I'm always seeing students doing, whenever they are told to pick final demand, they pick the final demand, the one that I circled, 100, 200. No, it must always be the new demand. Because you'll be told that demand, if demand changes too. So always use the new demand, which in this question I don't have. Always use the new demand, which in this question I do not have. So then I just wanted to use this question to showcase this particular concept like that. And then remember, if I am your examiner, I can't give you 2 sectors. I'll always make your life harder by giving you how many sectors? 3 sectors. 3 sectors, just like how it was brought in 2022. I'll be able to share with you in the group. All right. So then I have a request to make. I normally don't teach this kind of few students. These are 30 students. They are very, very few. I'm a man of big numbers. So the request is that we reschedule this class to 2 p.m. But now you get to your respective classes, tell your classmates to create time and attend. Because now in the afternoon, I'll be able to do great concepts. I would want to teach you hypothesis. I would want to teach you linear programming, especially the simplex table interpretations, great things. But I can't do that. You can see the energy I'm using is too much for 30 students. So is it possible we agree that you're going to the classroom and tell your respective friends there that they need to attend? So can you promise mwalimu like a minimum of 100 students? Yeah, great. Yes, that will be great. So exactly 2 p.m. Or we do after work, that most of them are working. Now, unfortunately, Brian, all my evenings are very, very committed. Remember here, I teach AFR, I teach AFM, I teach BDA, I teach so many papers. So all my evenings, if I promise you a class in the evening, I'll be lying. It has to be during the day when I'm very, very free. But the good thing again is that at RCM, we record all our sessions and we put them in the learning management system. So Brian, should you miss a class, like 1 or 2, you can always go back and watch the video. So, and I'll be uploading this video on my YouTube channel. I'll be sending you the link to that YouTube channel. Make sure that you give Mwalimu a subscription. It will be good to have you guys subscribing to my channel. Great. Can I make a good teacher? Can I make a good teacher? Am I a good teacher? Am I a good teacher? We shall overcome. We shall overcome. We shall overcome. So see you at exactly, thank you so much. See you at exactly 2 p.m. Thank you so much, 2 p.m. Thank you so much. You are the best. Thank you so much. Great. Yeah. Okay, great. I'll be able to do that. And if there are any students who are not students of RCM, please make inquiries regarding our block revision. We have great classes for block revision. Yeah. Great classes just for block release. We call them low-hanging fruits classes. And I'm the one who will be taking you through these block revisions. Yeah, from today to the very end. From today to the very end. The only other thing that I always go for in all my subjects, I always get awards. #1 student in Kenya, whichever subject I teach, will be coming from my class. So you must also promise me, if I'm going to take you through block revision, the day of block revisions, and you'll be attending all of them, you must promise this great teacher here that you shall become #1. Otherwise, see you at 2 p.m. Let's catch up later. Thank you. Yeah, if you are in RCM, the block revision is free for you, so long as you have paid fees, right? So long as you have paid our normal revision, our normal fees, revision is free of charge. We'll not be able to charge you anything. Already you are protected. Already you are protected. Foundation level, I only help students in QA, but we have other great teachers who teach these other subjects. But if you are looking for Mwalimu, I only help QA students. Yeah, QA students during block revision. And if you attend all of them, you are sorted out. Thank you so much. Yeah, they will be on the website, Abigail. They will be on the website. Thank you. Bye. See you later. Yes, I will be able to give you the schedule. Yeah, thank you. I'll be able to give you the schedule in a few minutes.